Our presenter today is Ronald Cruz. Ron is no stranger to all of us. His expertise and wealth of knowledge in mathematics has provided us with rich resources to assist ABE teachers in their implementation of the newly developed college and career readiness standards for adult education. As you participate in this webinar today, you will gain more understanding of the college and career readiness standards for ABE curriculum frameworks for mathematics. In particular, you'll learn more about the college and career readiness content standards specifically focused on statistics, the number system, and functions. You will learn more about the standards of mathematical practice, focusing on how they're applied to multi-step problem solving. And you will get a glimpse of the content and format of the upcoming CCRS ABE Math face-to-face trainings rolling out in February. So now, on to our webinar with our facilitator, Ronald Cruz.
Thank you so much, June, for that introduction. Thank you, everyone, for spending precious time during your day to participate and to view our webinar for today. Hopefully, you will be able to gain some much-needed information and will be able to increase your comfort level in the implementation of the College and Career Readiness Standards for ABE Mathematics. Let's start off with the overarching goals of this webinar. Pretty much what we're trying to accomplish in this webinar is, again, is the main focus of everything we do in professional development, in our classrooms, and our overall goal is to increase your understanding of these college and career readiness standards. We want these webinars to be able to eventually empower you to implement the curriculum framework for mathematics. We're going to do some modeling and collaboration during this webinar, and we're also going to be sharing with you some really good resources that you can use. Our end goal with that sharing process is for you to be able to become more comfortable with these resources and eventually create your own resources that fit your own teaching style and philosophy. We also wanted to look at and focus on the improvement of students' readiness for post-ABE goals, whether it is for them to get or enter into a GED preparation program or take the GED test or even take a vocational training. And hopefully these instructional strategies that we model in this webinar can be easily adapted and applied in your classrooms. And again, that is our goal is to gear you towards improving the achievement of your students in the classroom. By the end of this webinar, we are expecting you to have a little bit more comfort level and be able to demonstrate increased understanding of the college and career readiness standards, applying the key shifts, focus, coherence, and rigor, which has been covered in our previous webinar. If you are curious and you've missed our previous webinar, just so you know, you can log in to the IFDAY website and pull up the Part 1 of the College and Career Readiness Standards for Mathematics, and you can view it at any time at your convenience so that you can still get the information that you missed, just in case today is your first time participating in this series of workshops and webinars. Again, effectiveness in the implementation of the College Career Readiness Standards for ABE would just be beneficial to you and to your students. What we're going to do is just like the format that we do everything in these webinars is first we talk about the theory behind the strategies, the theory behind the curricula and the curriculum framework, and then we apply them in a very appropriate environment, which is problem solving. Problem solving, I think, is one of the hardest skill the students have to learn in your classroom, and then when they go in and they go to their post-ABE goals, that's where they encounter most of these. So we as teachers need to do a good job in really modeling and monitoring how students solve problems, because it would just be so much beneficial for them when they enter and move on to their post-ABE goals. So as you may know, the College and Career Readiness Standards for ABE Mathematics, the curriculum framework is divided into 10 different domains. The base 10 numbers and operations, algebraic thinking, measurement and data, geometry, fractions and operations, expressions and equations, the number system, ratios and proportional reasoning, statistics and probability, and also functions. Just so you know, these domains are not in any particular order on how they should be taught. One of the things that I learned as a teacher is to start with which areas my students are really struggling with. So, but also keep in mind that in order for you to be able to do fractions and operations or get into the fractions and operations unit, students had to have already some base knowledge of the base 10 numbers and operations, some sort of algebraic thinking so that they can move on into the manipulation and operations of fractions. So there is a hierarchy in these domains. It's just that we should not be teaching them at these in this particular order. We, as a teacher, have the liberty to pick or sequence these domains that will best fit the needs of our students. So let's look at these content standards a little bit closer. What I did is I took a snippet of one of the content standards that is in the curriculum framework, and I focused solely on one of the things that is least touched by majority of the ABE teachers, which is statistics and probability. You know, just based on my observation, the comfort level of teachers teaching the higher level ABE domains just decreases. It's not very high, and that's why the focus of the Part 2 webinar is to really hone in these more difficult, more complex domains so that teachers will have an increased comfort in teaching them and also in facilitating classroom activities that focus on these standards. So we're going to take a look at these this one snippet of standards. On the left column, you will see NRS level 3, and on the right column, you will see the NRS level 4. What do these all mean? So that area that I just labeled on your screen is the level determines the level of the students in the ABE level. As based upon the NRS standards or the NRS cutoff scores. And now, this one right here on the upper left corner will show you what domain. So if you're looking at it right now, there is like a numerical code up there, and then you see underneath that code statistics and probability. That's what we call, that's where you can locate the domain. Now, the ones in bold are your anchor standards. So you see two anchor standards on your screen, 3.1, which is develop understanding of statistics, of statistical variability, and then 4.1 is summarize and describe distributions. What is located underneath those bold headings are your benchmark skills. So if we look at carefully underneath the 4.1, we have two benchmark skills that are itemized under this particular anchor standard. And the first one, letter A, is summarize numerical data sets in relation to their context. And then letter B, relating the choice of measures of center and variability to the shape of the data distribution and the context in which the data were gathered. Now, what I wanted to do right now is kind of walk you through, because a lot of the teachers may not have seen these curriculum frameworks before, and for some of you who've already been using these curriculum frameworks that has been released by the Department of Education, this would be another great practice for you to really hone in and start unpacking these standards. Initially, if you just copy of the standards and provide them to your students, really it will not make a lot of sense to them unless you really explain it to them or really break it down to what it really means. So giving the students the simple anchor standard doesn't really tell them so much of what they're supposed to learn. And not until you get into those benchmark skills that really tells them these are the things and the skills and the content that needs to be drilled with the students. So let's look into, again, to the other content standards under the statistics domain. So as we look into these and start unpacking these content standards, I'd like for you to look for skills that students need to master. Look for key concepts that students need to understand, and I will explain this to you in a little bit so that we'll have a better understanding of what do I exactly mean when I say key concepts. Look at the hierarchy of skills and topics to have a better approach to the statistics domain. Again, the order on which they are listed in your curriculum framework doesn't necessarily dictate how you can start. Some of the statistics skills are separate from the other statistical skills that you can teach them separately from others. So there's a way that we can do that, and one of the things that those are one of the things that we're going to be talking about as we look into these content standards. And then think about what resources do you need in order to effectively teach the ABE statistics to the students. You know, simply looking at the curriculum framework doesn't tell you a lot, and it requires a little bit of planning. You know, the curriculum framework, just as it is a framework. Teachers still have to do their part in designing content and designing lessons, problems, activities for students to do in order for them to be able to develop the content standards. First of all, why is statistics even so important? So we'll answer that question, get it out of the way before we even start looking at what statistical concepts and skills students have to learn. First, it is tested in the multiple modules of the GED test. If your students are aiming to take the GED and pass the GED mathematics test, they will know that every single module of that test battery have some sort of statistics embedded in it. So really, we're getting the biggest bang of our buck if we teach statistics to the students in the ABE level, because then they will have that foundational knowledge in all of the subject area modules. It's readily applicable in all subject areas and fields, just like I said. Why is it tested in multiple areas? Because it is readily applicable to these subject areas. Statistics is all around you. What season is it now? Primary season, and soon enough it'll be election season. We are bombarded on television with statistics. Super Bowl just finished, and right before the Super Bowls, what are people looking at? We get into these games, and we get into these betting, and we get into these Super Bowl parties, but people don't realize there's so much statistics in those events that really it doesn't require a lot for you as a teacher to really motivate your students into learning statistics. And most importantly, statistics help us make informed decisions, whether or not which team is going to win the Super Bowl based on the statistics of each player, which candidate for president had the most accomplishments or whatnot. There's several things that we can use. It could be even daily things that we do in our lives. Which item is the most trusted? We read reviews on Google, and we look at statistics every now and then, and really makes us help pick the right choice. And according to the Boston University of College and Arts and Science, this is something that I picked directly and an excerpt from the website. Medical studies to research experiments from satellites continuously orbiting the globe to ubiquitous social network sites like Facebook or Twitter, from polling organizations to United Nations observers, data are being collected everywhere, all the time. Knowledge in statistics provides you with the necessary tools and conceptual foundations in quantitative reasoning to extract information intelligently from this sea of data. So just you can see with that snippet, they put in, students get really involved themselves in statistics, and they're really going to get into it once you incorporate all of these other things where statistics is readily available, readily applicable to. So now let's look at this statistics domain. Just by looking at this first domain, let's focus on the left column on your screen, develop understanding of statistical variability. So now, how do I start? As a teacher, what do I have to look at? You know, I am lost in this sea of vocabulary words. And first the key is just piece it out. You know, let's look at the anchor standard. So the anchor standard is talking about variability. Okay, and then you see here in the left column you have statistical question mentioned several times. What are the different types of statistical questions? I don't know exactly what that means right now, but let me read a little bit further to get a little bit of a context of what these statistical questions are. Statistical questions focusing on variability of the data. Okay, statistical questions looking at the center, the spread, and overall shape. So these are really important keywords that we should already preempt before even going into the actual lesson. You know, pick a particular statistical information you want to show. It may be a survey that was conducted by a newspaper, or it could be your Twitter feed and see how many visits. They do a lot of statistical analysis on your Twitter and your Facebook. You'll be surprised how much data Facebook collects on your personal social networking website. And just by looking at those, look at the different types of variability and center in the data that you are involved with. It could say what is the average number of, or the mean number of posts or comments that you put in a day. You know, those are the types of things that you can really entice your students to get into statistics a little bit more, especially if it concerns their social media page. So again, we're going to talk about those measures of center. It's been repeated here many, many times. And we're looking for that single number. That single number we usually refer to as either the mean or the average. This is a very basic skill the students need to learn. It's a very good application of their algebraic thinking and manipulation. So really, this is something that would, you know, that could be easily be reviewed with your students. Next, let's look at the right column. The right column is a little bit more higher level because it's now at your NRS level 4, meaning you're going to be required to do a little bit more complex analysis, manipulation, and computation based on what you learned from your NRS level 3. So from level 3, you're just discussing. You know, that's kind of pretty much the expectation at the level 3. Students should be able to describe a particular set of data given to them, describe the variability. What is the range of the data? What is the mean, the median? If there is a mode, what is the mode of the data? Those are the types, there's the expectations that are at the level 3. But when you move on to your level 4, now it's going to be a little bit more complex. If you look at it, the expectation now for the student is focusing more on summarization. Summarization of data, meaning reporting the number of observations, describing the nature or the attribute under the investigation, using quantitative measures of center, such as median or the mean, giving quantitative measures of variability, and what those measures are the interquartile range, I'm going to circle that real quick, and the mean absolute deviation. Wow. I'm going to stop right here, because then if I show this to students, the ABE level, you know, they may be in the advanced ABE level at the NRS 4, even those advanced students would be a little bit taken aback by the vocabulary that we were just bombarded with a few minutes ago. So now they're going to introduce a little bit more complex. So the mean, the median, and the mode are very simple operations in describing and reporting data. But now we're going to introduce to them how to find that interquartile range. Do we even know how to do that? How about the mean absolute deviation? So sometimes I'm not a statistics major, but when I first looked at this curriculum, or when I first taught the statistics unit to my students, I had to do a little bit of research, and I had to to look at sample problems. I had to look at definitions. I had to study how to really study and practice how to find the interquartile range and mean absolute deviation. Now your students will say, "Oh, why do we have to learn this complex math operation just to get a single number to describe our data?" This is really a really important teachable moment for you as teachers, because when you go into our face-to-face workshops, we are going to show you ways on how you can really encourage and engage your students with these two concepts. We're going to show you various strategies and activities that you can do with your class to really emphasize the importance of these two operations. So that's all for that. The rest are pretty much a reiteration of the level 3 NRS statistics and probability anchor standards and benchmark skills. Now let's look even further, and I'm not going to spend too much time doing this because I just modeled that first block to all of you. And now I want you to take a little bit of time, look at what's in front of you, and also, just so you know, the College and Career Readiness Curriculum Frameworks for ABE Mathematics is in your handouts, which is also in the IPDAY page. When you logged in, the handouts and the materials are already there. You can pull it up, save it to your computer, save it to your desktop, and start working with it. Okay, so right now I'm going to take a moment and stop for a little bit and let you all look at the standards and the benchmark skills that are in front of you. Now I'm going to take a little bit of time, and I'd like for you to please type into the chat box or the question box, what are the key things that we have to teach students when we're looking at these 3 boxes of anchor, standards, and benchmark skills. So you can go ahead and type in the information you need, you see, and then I will be I'll be taking in some questions as well. If you have any questions from the previous slide or from the previous unpacking that we just did, you can go ahead and post that question as well. All right. So in here, on the level 3, NRS level 3 standard, how do I know which one is level 3 and which one is level 4? If you look at the numbers, so the number 3 on the upper left corner box, that indicates that it is an NRS level 3, and if you go to the right column shows you the NRS level 4. All of these 3 boxes that you see in front of you are all under the statistics domain. The anchor standards for level 3 has some summarization already involved with it, but it's still a continuation of how to describe different distributions. We need to expose our students to various data representations, including, but not limited to, dot plots, graphs of data using dots, histograms. How is that different from a bar graph? Box plots. That's my first time hearing that. Those are the things that may be going through your head as you're starting to read through and highlight through your statistics domain. But again, it gives you a little bit of information what those are in here, but this is not enough. I do not suggest just to use your curriculum framework as a springboard to designing your lessons. You're going to have to do a little bit of research on the side to find out what these data representations are. So, and if you participate in our upcoming ABE CCRS math face-to-face workshops, which will be starting on Friday, you will be bombarded with all these different types of data distributions and data representations, and then you can take those back with you into your classrooms and readily implement those strategies with your students. So then on the right side, we're going to look at that. If you see more, the focus on the right side on the level 4 is more on random sampling this time, or looking and examining multiple samples. So that means we're not only now looking at a single set of data, we're now looking at multiple sets of data. One of the things that's important for us to do that is so that we can make comparisons in order for us to also make causal relation. Does one cause the other? Those are the different types of things we need to be looking at, and we need to be talking to the students about when we enter into the random sampling and multiple samples area. And again, you see how one of the major shifts is really implemented here. If you look at the bottom portion, you spiral back to the use of the mean, the median, the mode, the interquartile range, the mean absolute deviation, and the range. So a lot of those you're going to have to review again, because this time we're now going to use them to draw informal and comparative inferences. So if you're looking at the mean, what does it mean when the average yards that somebody earns in a game, or in, let's say, in a quarter of a football game? What does that mean? What is the inference that can be drawn from that particular piece of information? And I'm going to go ahead and move forward. Then in your slides, you will see a lot of these things. You will see a lot of the applications of statistics, and one of the really, really good application of statistics is probability. Okay, one of the ways that we do that. So you will see a lot of probability being introduced now at this level, and using statistics to really predict something. All right. So that's pretty much it. I'm not going to spend so much time, and I'm not going to do this all for you, because there really is value in you on your own time, during your planning time, during your free time, or during the time when you're given an activity for students to work independently. It would be really, really advisable for you teachers to start looking carefully at what these standards are looking for in terms of skills that students need to master. All right. So I'm just going to skip over this slide, and then let's move on to the standards of mathematical practice. So far we've talked about one set of standards, okay? The set of standards that are content-based, okay? So statistics and all of those anchor standards and benchmark scale belong under the content standards. But there's another set of standards that we should be teaching alongside, modeling, and monitoring alongside the attainment of the content standard, and that is the standards of mathematical practice. So there are 8 standards of mathematical practice, and the first one is make sense of problems and persevere in solving them. The second one is reason abstractly and quantitatively. The third, construct viable arguments and critique the reasoning of others. The fourth one is model with mathematics. The fifth one is use appropriate tools strategically. Next is attending to precision. Next is look for and make use of structure. And the last one is look for and express regularity in repeated reasoning. Now, again, I do not bore my students nor overwhelm them with the wording of these practices. Sometimes the wording of these practices kind of turns them off right at the moment. I'm like, oh, you're using so many big words, Mr. Cruz, in 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 describing what we're trying to do when we're solving a problem. What I do is I kind of made the words a little bit simpler for my students to understand and go straight to the point. I kind of simplify the wording so that it's not so threatening to the students. It's not so much as they know what the mathematical practice they're applying as it is to knowing how to really do the practice, if you get what I'm saying. So really my focus is for the students to actually practice it and not so much memorize these standards of mathematical practice. And as we do a word problem, or as we do multiple activities in class, not necessarily a word problem, it could be a worksheet, it could be fill in the blanks, it could be a matching activity, it could be even a game. But in all those things, I do not forget to point out what standards of mathematical practice we're actually implementing at that time. And when I see a student, a particular student, that is independently applying these mathematical practices without my support or without scaffolding, then I highlight it and I recognize the student who does it. So in order for us to gain a little bit more understanding of these mathematical practices, we need to see it in action. So what I did is I'm going to solve a sample problem for you, and then I'm going to highlight and point out the mathematical practice. And I picked a problem where almost all of, I think I've applied all of the mathematical practice in the various steps of the problem. So the problem that you're going to see in the next slide is really a multi-step problem. So don't expect the student to be asked this entire problem in one question of the TABE or the GED test. This means that this problem may be split into 3 different or 4 different items on a particular math module. So let's look at this problem right here. So I'm going to give you read silently as you read with me. Below is a sampling of student responses comparing to the hours they spent studying per week and their grade point averages, or the GPA. Using this sampling data, predict the grade point average of a student who only studies an hour per week. So now, before I even go into working out this problem, because I will have those really smart students that will immediately jump into solving the problem. I would also have those students that would not know where to start. So where do I start, and how do I marry those two groups of students that are really polarizing my approach to word problems? One way I solve that problem is I kind of just ease their mind as to I stop everybody, don't start solving it. I remind them we're not solving it right now. Let's just talk about it, so that helps ease the anxiety of your lower achieving students, and it kind of helps them kind of bring them into the situation first, and then incorporate their personal experience and their prior knowledge to help them really find an approach to this problem. So I begin this problem by saying, okay, well, let's look at that. You've got yourself, your brothers, and your sisters who've been, who have at some point in time talked about their GPA. And and then I ask my students, okay, based on your experience, what do you think is common with those students that have a very high GPA? What do you notice are common with them? And then I start asking the question, do you think is a correlation? I throw in that big word in there, but I just ask them, is there a relationship or a correlation between how many hours you spent studying versus the GPA at the end? And then your students will start thinking. So they're not really solving the problem, but they're really thinking and discussing amongst themselves and say, well, sometimes if you study more, you get a better grade. So that's really the types of response along those lines. Those are the ones that I'm looking for. And then I'm going to dive in and jump into the mathematics and really show them there's really a way to figure it out in a more scientific and mathematical way. So as we do that, we are applying two mathematical practices: making sense of problems and persevere in solving them, and then also looking for and expressing regularity in repeated reasoning. So some of my students will look at, ooh, let me look at these hours spent and let me arrange this in increasing order, see how it looks like. Because some students would do that, you know. And actually, I really advise my class and my students to arrange the data as it best makes sense to them. And one way to see pattern or regularity is to arrange something in increasing or decreasing order. Some of my students will sometimes even group the data. So how many students here studied for 2 hours? How many students studied for 3 or almost about 3 hours? Or they can even group them by grade point average and make that comparison. It really doesn't matter at that point in time, because what students are trying to do at this point of the problem-solving process is to really find an approach to solving the problem, but at the same time helping themselves make sense of what the problem is. What are they asked to do? You know, how do I best get to it? How do I best find a way so that this problem really makes sense to me? So not every student will have the same approach to data. That if I need you to validate the different approaches and not just what the teacher's approach is. You might even be surprised on if the students group them by hours or group them by kind of a range of grade point averages, that they would see a relationship that way as well, which is so important in the mathematical learning process. So now, these are the things that I'm looking for when I engage them in the beginning stages of the problem solving. I want them to look entry points to the solutions. If they know what to do, how do they start? Or if they don't know what to do, I want them to analyze what's given. Is there missing information in the problem? Is there any type of relationship between the information given to me? And this particular, that's the most applicable, is the relationship. And then what is the goal? That's ultimately where they want it to be. But in here, what we're trying to do is figuring out a way to find a relationship between how many hours I spent studying to my grade point average in the end. And then ask the students, like, okay, so if you know what to do and you've got the relationship, how do you solve it? Where do you start? And that's when we start talking about, oh, let me arrange this in increasing order and see if it's increasing. You know, if as the hours spent studying per week increases the grade point average, or as the hours spent studying per week, does it decrease the grade point average, or is it random? You know, those are the types of things that students need to be looking at the beginning stages of the problem-solving process. So now I've displayed the problem again to you. And then this time we're going to look at the quantities and variables. So there's two quantities we're looking at, is the number of hours and then the grade point average. They can circle the word grade or they can circle the point average, whichever word makes more sense to your students. Remember, they're not being graded as to how they analyze the data. It's how they make the data make more sense to them. That's what we're really looking out for as teachers. Which ones are independent or dependent? That's a really important question when you're moving into statistics. And not only in statistics, because when you move on to the next domain, you will encounter functions, and that's when you really are going to need a deeper understanding of what are independent and dependent variables. Now, so in this set of data, which set of variables, is it the hours or is it the averages, are independent of the other, and which one is dependent on the other? Now in here, we've already made that association. We just, I just mentioned earlier maybe my assumption is as I study more, then I get a higher GPA. So that means that the that means that the value of my GPA is really determined by the number of hours I study. So pretty much that's already a clue as to which one is the independent and the dependent variable. So in this case, the dependent variable is the number of hours spent studying per week, and the independent variable is, and the dependent variable is the grade point average. How can we organize this data? Can we analyze it further? So again, we've already answered that question in our pre-discussion of the problem. At this point, the students will already be able to answer this question really quickly. Well, maybe they want to arrange it in increasing order or decreasing order. They might want to group the data into different groups or categories. Those are the different things that students need to be able to know at this point and do. And would a visual picture help? A lot of our students are actually visual learners. So having a visual of what we're looking at, because a lot of them students look at numbers, they get turned off with numbers right away. But you show them a graph or a pie chart or a pictograph, something that is very visual, students would be able to connect immediately and make initial inferences that are very important to setting up those first few steps in the problem-solving process. So in this case, I think the best way to approach this problem is to organize the data in something that makes sense to me, and then eventually use a visual model so that I can really dig in and analyze what's going on with these numbers. As you do those things, you are applying mathematical practice number 7 and mathematical practice number 4, looking for and making use of structure. So when we start arranging them in order, when we start finding the relationship between the two, when we start grouping them, we are actually putting together a structure in how we're going to approach the problem. Also, as we create a visual picture of the problem, we are actually modeling with mathematics. So let's continue the problem. Now, graphing is just one way of really illustrating a problem, and in this case, graphing is the really most appropriate way to attack this problem. And you don't have to have a graphing calculator in order for you to teach this problem to your students. There are many ways. They can graph using a plain paper. They draw their XY axis and all of that. They can use a graph paper. Graph paper is very inexpensive, and I use that a lot in my class. And then a graphing calculator, if you're one of those fortunate ABE teachers that have a set of graphing calculators, it would be nice to start getting them introduced to those things. And a computer. Again, students, a lot of our standardized tests are now being given or taken using a computer, sometimes even a touchscreen computer or a tablet. So we need to start exposing our students to these types of technologies so that we really battle the anxiety of the students when it comes to taking the test. We've already won half the battle if we are already implementing somewhat the format of the test in our daily classroom activities. And that is really determining what tools to use is really a mathematical practice. And it's mathematical practice 5. Use appropriate tools strategically. And in this case, I don't want to be fancy, but in this case, I use Microsoft Excel because a lot of my ABE students, they really wanted to get into the accounting and QuickBooks class, and really introducing them to the basic application of Microsoft Excel and the mathematical capabilities of this spreadsheet program or application really allows us to dig in and analyze the mathematics to its core. So in this case, I just simply used Excel. I just typed in the two data. I re-entered the data there. And then with Excel, you can do many, many things. You can sort the data in increasing order or decreasing order. You can group the data. You can by copying and pasting cells and putting them in different areas of the spreadsheet. But in this case, I want to be a little bit basic and just try to keep the data on its own and let Excel do the arrangement for me. So in this case, Excel has this magnificent toolbar that's called charts. And if you highlight the set of data, you can display your data in multiple different ways. It could be a scatter plot, it could be a line plot, it could be a histogram, bar graph, even a pie graph. And that's the toolbar that I'm going to use. And then when I click on scatter plot in the Excel functions, this is what I got. Like, ooh, is that? What do you see? You know, when my student starts generating these graphs, remember, keep in mind that your students' graphs might be a little different depending on how they arrange their data and how they assign the variables if they're really savvy with Excel. But majority of your students will generate this type of graph using Excel. And then here, I kind of see a little bit trend going on. I kind of see the pattern here. But then I throw that question to the students. And what do you see? How do you analyze that? You know, and really that is another mathematical practice, attending to precision. You know, looking at the graduations on my on my X and Y axes. How do I want it? Do I want it in increments of 0.5? Or do I want it in increments of 2? And in this case, my vertical axis is in increments of half a point. And then my x-axis is in increments of 2. Now your students can set these up in many, many various ways. They can do increments of 1, they can do increments of thirds and fourths and all of that, which is a good review of your fraction skills and decimal skills. Now continuing to that problem and using appropriate tools strategically, excuse me, there is this special function that you can click on the graph and show a trend line. That trend line will show me somewhat Excel's interpretation of the best fit line, or a line that would best describe the behavior of my data. And if you click and check that box, Excel automatically draws it for you. You really don't have to do anything. And again, I'm not trying to remove the thinking and the critical thinking aspect of this by using the Excel. I just want the graphing, the tediousness of graphing to go away, because eventually a lot of the questions they're going to encounter, they would already have graphs and trend lines in them. So really, we're not training the students to be able to draw the trend line, but really understand what trend line means. So in here, we're looking at it and like, oh, okay, so there's it kind of goes a straight line. Is the line going left to right? Is it completely horizontal? Is it slightly increasing as you go from left to right, or decreasing from left to right? Those are the next questions I pose to my students as we move on to this problem. Now, in order for me to be able to draw the exact trend line, I have to have 2 points. You know, I still remember my math teacher talking about, 2 points make a straight line. And eventually, when I go into college, I realized, no, 2 points is not just 2 points make a straight line. There's infinitely number of points in a straight line. So anyway, as we go into this problem-solving procedure, you will notice that I need the point, and where would that line cross? And one of the best ways to do that is to find the mean or the average GPA and the average number of hours spent studying per week. Why do I need to do that? And I'm going to show you why. So first, I'm going to try to get the average number of study hours. So I do that by adding all of the hours right here at the top, and then dividing it by the total number of data points that I have, and I get 5.5. And I'm going to do the same process with the GPA. And in this case, I'm getting 3.03. This too, I'm going to pair these numbers together, and I'm going to call them a little bit of a fancy name called ordered pair. Now, when I start sticking that ordered pair word to describe the 2 numbers I just came up with, students, the light bulb starts clicking. So we need to graph this point? Yes, definitely. You really have to graph this point and see where it is on your graph. So let's do that. Well, before we do that, let me point out the mathematical skills that we're doing here. Using appropriate tools strategically is one way that can be applied in this part of the problem-solving process, because they can use a calculator to do this. Some students may even do this by hand if you want to practice them with long division, that type of thing. So pretty much that. And then reason abstractly and quantitatively. That's when we have found that ordered pair or that point where our line will cross. So now what I did was I threw that point in. You see that red dot on the graph? That's the additional point that I graphed when I plotted the ordered pair we got from the previous slide. So that's where I put them in. And that means that's where my line is going to cross. So in here, construct the line of best fit or trend line that passes through the mean values. The mean values of the grain point average and the mean values of the hours studying per week. And now I'm going to pause for a bit and then see if there's any questions so far before I move on. Here, yep, I've got some comments over here. Definitely need vocabulary before they can work with the problems. Exactly. You need to stop those students that are jumping directly into solving that problem and start talking to them, having conversation with them as to what words are in here that you're not familiar with, and if you're not familiar with them, what do you think they mean? And it really taps into that prior knowledge of your students. So yeah, that's the one question that I've got so far pertaining to the word problem that we're working on. And then now I drew my trend line. And then in order for me to draw the trend line, I just asked the students to orient a line in such a way that it's closest to majority of your points. Okay, and in this case, this is the best I can do. And it happens to be falling on the same dotted lines that Excel did. And again, using Excel is the best way to do this. You can do this using a graphing calculator. You can even do this using a graphing paper and a ruler and a pencil. So really there's nothing preventing you from doing the same activity even if you have limited resources in your classroom. And then you are applying Mathematical Practice 5 and Mathematical Practice 2 in this particular problem. In this case, we are now reasoning in an abstract fashion because of the fact that we're drawing a trend line to describe the behavior of our. So now that we have that, now that we have that, we can make even a prediction as to in order to answer the problem. So I'm going to go to the previous slide a little bit because I lost the word problem. So let's revisit the word problem real quick because we kind of lost track of what that problem is asking us to do. The grade point average of a student. So we're trying to predict the grade point average of a student who only studies for 1 hour per week. Okay, so let's keep that in mind as we go into that slide. Okay, so as we see this graph, how do I figure out if I have this graph already and it's in increments of 2, and then I wanted to, hold on for a minute. If it's in increments of 2, then 1 would be somewhere between 0 and 2. So I need to know if in this point in time, how much time, if I studied for 1 hour, what would be my GPA at that point? And then I kind of simply drew a dotted line there to kind of mark that point. And then I asked my student, can you estimate the intersection? Where does that dotted line intersect our trend line? And that could be a really good estimate of the GPA of that particular student who only studies for 1 hour per week. One of the reasonable estimates for that GPA would be If a person studies for 1 hour per week, it's going to be about 2.6. You know that it's going to be above 2.5 over here, so it's going to be a reasonable estimate. Your students can even say 2.65 or 2.7, depending on how well they graph their trend line. But at least they're in that vicinity of the correct answer. And again, we're applying mathematical practice number 2 and mathematical practice number 3. This is now when the student starts analyzing what those answers mean and construct really valuable arguments about how they solve the problem. That's when they apply this mathematical practice. And then we go back and really reinforce that mathematical practice, and I showed the students' work to the entire class and say, okay, let's start critiquing the reasoning of your students. Because some of your students will draw a line and arrange the data in a decreasing fashion, and then so that would require a different way of looking at the data. And that's what this means when you're looking at the mathematical practice number 3. So again, just to review, keys to understanding statistics is to understand how the data is organized and represented. What is the purpose of that? It could be, statistics could be used to mislead. We've seen how people sometimes use and overinflate statistics just to encourage people to buy their product. Understanding how to draw conclusions based on a set of statistics, and understand the different factors that may affect statistics upon population size, sample size. These are a lot of vocabulary words that students need to already understand prior to getting into the statistics unit. And then lastly, I just wanted to give you a brief summary of what we just did for the past hour. So in this workshop, we demonstrated all of these shifts, but just by looking at the content standard and just by looking at the mathematical practices and one word problem we solved, we understood how effectively how to implement the college and career readiness standards, that it stays true to the shifts in the mathematical practices, and then we solved the problem, in here. So now I am, if you really, really like the approach or how I pieced apart the mathematical practices, and I really wanted to invite you to explore what IPDAY has to offer in terms of increasing your knowledge and comfort level in the college and career readiness standards. So I'm going to turn, right before I turn this over to June, who's going to talk to us about these aligned resources to what we just talked about today. I'm posting in a QR code. You can scan it using your phone, or you can type in the SurveyMonkey link into your browser. I'd like to hear your comments. What do you think about this webinar? Was it helpful? Was it not? How do you want it to improve? Please go into that page and all of that. I'm going to turn over to June and to talk to us about the different resources available to us aligned to this CCRS webinar.
Thank you, Ron, so much. That was a great webinar. Well, I just wanted to point out that today's webinar is just a part of many IPDAY resources that you can use to gain more knowledge on the CCRS standards for mathematics. So now I'm going to have Ron pull up the IPDAY website because I'm really excited to announce one of our new resources that we have on the IPDAY website, and it's called the IPDAY E-Training Center. If you go to the landing page of the IPDAY website, you'll see it right up there at the top. Ron's pointing to it now, called E-Trainings. Then you'll go into your portal login up there at the top right, and it will display the E-Training Center. Now you can log in and view the trainings that are offered in the E-Training Center. Here's your dashboard. That is your personal dashboard that's going to show you all of the activity and everything that you participated in IPDAY with. But let's log into the e-training catalog, Ron.
Okay, so there's two ways to do that. You can do it up here, or you can even go over here in the e-trainings catalog.
Perfect. And then this is going to show you all of the modules that are now open that you can go through and take. And let's just pay attention to this math one, because in this case you might want to select the math, and you just simply select it and you enroll in it and you receive a certificate at the end. As IPTE rolls out these professional development resources associated with the CCRS standards for ABE math, keep in mind that our focus is to empower you as teachers in helping your students achieve their academic goals. So on behalf of IPTE and the staff at the Florida Department of Education, and Ron, thank you so much. We thank you for joining us today at our webinar, and we hope that you'll join us next Wednesday and every Wednesday throughout the month of March as we bring you more webinars that will be ones that you'll enjoy watching. Thank you for your time.